Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others who want to test their math skills with these types of test questions. So this will be our 25th part in the series, and what we got going on here is that we have to determine the area of the blue region inside this regular octagon here. So we're looking for this little blue squarish thing right here. So we are also told that each green square has a side of 4 centimeters. So we have 4 squares inside of this regular octagon. Now, a regular octagon just means that all sides are the same. So this would be 4 centimeters all the way around for all of these sides over here. And we're also told that each green square has a side length of 4 centimeters. So these green squares align perfectly with the sides of this regular octagon. So how are we going to do this? Well, what we're going to do is we are going to look at one specific portion of this octagon at a time. And the reason why we're only going to look at one portion is because, well, it's a regular octagon, so it's the same all the way around, filled in with 4 equal squares where all their sides are exactly the same. So what that means is that this little portion right here that I'm looking at will be exactly the same for this one, exactly the same for this one up here in the top right, and the same for the bottom right as well. So figuring out some dimensions inside this portion right here will be equivalent to finding them on this one, and this one as well, since everything is a regular octagon and everything is an equal square on the inside. So let's go ahead and blow this portion up and see if we can find some dimensions here so that we can get to whatever this dimension is right here. All right, so blowing up this portion, this is what we have in that bottom left-hand corner. Now let's put on some points here. So we're going to call this point A. This intersection we're going to call point B. This one down here we'll call C. We'll call this one up here D. We'll call this one E. And then we'll just call this one F for right now. And then we'll just keep working our way towards the center here. Now, right here will be my 4 centimeters for my square. Oh, sorry, not all the way there. So that green square edge is right here. So there's 4 centimeters. Same thing with this one. This is also 4 centimeters for the green square as well. And then this side A to C will also be 4 centimeters for the regular octagon. All righty. So what I'm going to need to find here, because I'm going to have to find some dimensions working in here. If I can find what this dimension for AB is, then I can find out what BF is. Because BF would just be essentially 4 centimeters minus off this X dimension from A to B. BF then would give me what DE is, and the same for EF. Because when you have squares intersecting like this, and you'll see here when we work through the math, that these dimensions right here will be equal to this. And what we have is a little square here because all of this intersecting will be 90 degrees with equal length squares intersecting in a corner. So let's go ahead and let's start working through this. So how do we get this dimension X over here for AB? Well, this is a right triangle forming here, and we already have a hypotenuse side. So in order to find this dimension over here, we need to determine what this angle is here at C, or we can use the angle at A. It's going to be exactly the same for a regular octagon. So a regular octagon, all your angles for the octagon will be a total of 135 degrees. So what that means is that this angle right here is 135 degrees. Well, this angle for the square will be automatically 90 because, well, it's a square. So if we want this angle, this internal angle for this triangle here at C, we would just take 135 degrees, subtract off 90 degrees, and that leaves us with a total of 45 degrees internally here. So this would be 45 degrees. And since this is a triangle, well, look, 45 degrees on the opposite side as well for the right triangle. And you could have done that same process that we just did up here at A if you wanted to prove that. So what this means is that this dimension from A to B will be exactly the same as this dimension from B to C. So it doesn't matter which one you actually look at, but let's just go and stick with AB here. So in order to find AB, we will take the sine of the angle 45, or you could do the cosine, doesn't matter, is equal to AB over that 4 centimeter hypotenuse. Well, AB would just be 4 times the sine of 45, and that gives us 2 square roots of 2 centimeters in length. So that would be the same for this one as well down here for B to C. So let's go ahead and let's find BF and DB here. Well, BF is going to be equal to DB because we are 4 centimeters on each of these, and the X dimensions are exactly the same. So this would just be my 4 centimeters, subtracting off my 2 square roots of 2 centimeters. And I'm going to leave it like this just for right now because it's not a very nice number. So we'll just leave it as 4 minus 2 square roots of 2. So since, let's just call that 4 minus 2 square roots of 2, let's just call that y for right now. So since this is all 90 degrees, as I just said earlier, and we have two sides being exactly the same length with 90-degree angles, that means we have a little square forming here. So that means that DE, EF, BF, and DB are all equal to each other. We just proved that. So DE is equal to EF, which are all equal to this magnitude right here. Okay. So if we scroll back up, what that means is that we have found all these dimensions leading in here. Now, we have this dimension right here for this line at the top of the square. We know that the overall top of the square is going to be, well, it's going to be 4 centimeters. If we were to repeat the process that we just did on this side right here, this bottom right, we would also determine that this portion right here is equal to that portion over there, being the 4 minus 2 square roots of 2. And you could repeat that process all over, getting this, and these dimensions, and then repeating the process for this one, and this one as well. And what you would end up proving is that this is actually a square that forms inside here. Now, I'm not going to show the repeated processes because it will just be the same process that we went over, repeated 4 times. So let's just cut out this new area, knowing that we have a square here. I shouldn't have done it in blue because it goes right through that blue region, but you get the idea. We're going to cut out this portion right here and blow it up and work with it. So this is what we have going on right here. And let's stick with red because it seems to show up pretty good. All right. So this was point D. This was point E. And let's just put on some new points here. Let's call this G. Let's call this H. Call this J. And let's call this K. Well, we know that DE is equal to the 4 minus 2 square roots of 2 centimeters. Well, that means that if we repeated that process, this is also equal to GH. And we know that the total here from D to H will be 4 centimeters from the start. So DH would be my 4 centimeters. And what I'm really looking for here is I'm looking for whatever EG is. Because EG will be equal to JK. Oh, give me back my pen. Is equal to JK, which is equal to EJ, and is also equal to KG. So basically the sides of this little blue square. So if we find one of them, we just have to square it to get that area. So let's just focus on getting EG here. Well, what is EG? Well, EG will simply be D to H all the way across, subtracting off the 2 portions here of DE and then GH. So subtracting off DE and subtracting off GH. Well, we have all those dimensions known, so this would just be 4 centimeters, subtracting off 4 minus off 2 square roots of 2 centimeters, and subtracting off that once again with 4 minus 2 square roots of 2 centimeters. So you just have to watch out for the minus sign transferring into positive signs, because this would end up being 4 minus 4 minus 4 plus 4 square roots of 2, which this equals 4 square roots of 2 minus off 4 centimeters. Well, that would be my length, and it's asking for the overall area in blue here. So my overall area in blue would just be this squared, because it is a square. And once again, you could prove that, but since everything is a regular octagon followed by 4 equal internal squares, everything would be exactly the same if you just do each corner. So what we have going on here would be 4 square roots of 2 minus 4 multiplied by 4 square roots of 2 minus 4. And this would end up giving me 16 times 2 minus off 2 times 16 square roots of 2 plus 16. And if you rearrange and simplify this down, of course, it doesn't come out to be a nice number. It'd be 48 minus 32 square roots of 2 centimeters squared, or you could write out in approximation decimal form, which is 2.745 centimeters squared. And that would be your area for your little internal blue square there. Keep in mind that we took a little bit of a shortcut here. Instead of actually going through and calculating each little portion here, we just realized that once we did it once, looking at the proportions of the numbers, that it's going to be exactly the same all the way around at each corner for the regular octagon, and having 4 squares internally, it would all be the same running through each corner. And this would be your answer at the end. So I hope you enjoyed this video, and I hope you learned a new math skill from it. And if you want to test your abilities even further, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a fantastic day.